Good afternoon, everyone. So this is in regarding a course on materials and environment. Although we covered most of the topics listed in the curriculum, but I understand that we have time with us, and that is why we can continue our discussion on one of the interesting topics, which is very much related to the topics that we have been referring to. We call it as circular materials economy. And I will introduce today the basic concept of what do you understand by circular materials economy, and then we move forward. When I talk about circular materials economy, and I say that it is a new concept, which simply means that earlier we are using some other concept, which I define as the linear materials economy. And let us see today what is the difference in these two terms, the linear materials economy and the circular materials economy. Now, okay. So when I talk about linear materials economy, this is what our traditional approach has been, that we have been mining materials, we have been creating materials, taking them to plants, manufacturing products out of the materials, and then disposing of those materials at the end of their product life. Although we have been recycling materials, specifically metals, for some time by now, but still only recycling does not constitute to what we call as circular economy. There is more to it merely than recycling, and that is what we need to appreciate. So if I talk about linear economy, this is, as I said, is the basic concept here, that we start with materials and we just use them and then discard the materials. The problem now is that because we already have studied that the consumption of materials is rising, and this consumption of materials, because of the increase in affluence, because of the increase in population, is actually posing now what we say a pressure onto our ecosphere, into our ecological system, and this is precisely the reason that we want to cut down on the material consumption without compromising on our lifestyle. Means I do not want to cut down the consumption of materials, but I want to cut down the consumption of resources. So there are two different things. I still want to make cars of steel, but I don't want to mine iron ore to more than the extent what I'm doing today, maybe in the next 20 years. The only thing then possible is that I do not discard the products at the end of it, because the products that you're discarding here, they may have lived their life, but they still contain materials. Almost all the materials are located in it. If you are able to recycle, or to you want to refurbish, or you want to re-engineer the components here at the end of their life, we will define them as nutrients. The circular economy concept actually defines them as nutrients here, and we will see that those nutrients will again come back into the system, and the materials will not go out of the cycle. So that is the basic concept of circular economy. The materials remain in a cycle, that they don't go out of the cycle here. Means I can still sustain the same consumption, and I can keep on increasing the consumption here because of increase in population and affluence, but still the resource consumption can decrease, because I'm not discarding the materials, I'm recycling the materials, I'm re-engineering the components there, and then the load onto the fresh resources or the virgin materials is less, and that is the basic idea behind what we refer to as circular economy here. So, as I already described, that presently what we are doing is take, make, use, and dispose method, which we say is referred to as the linear materials economy, and we have been doing it for some time. Although, as I already said, that we are already into recycling to some extent, and to a great extent in many of the in some of the materials we are recycling them at a great extent here, but still the concept of Circular economy goes beyond that. So this is our current concept. This is precisely the life cycle that you have the natural resources, you take them to the production site, then you make a raw material, then you take it to the product manufacturing plant. We then use the product, then we dispose the product. And this green line is what we refer to as recycling. To some extent, we have been doing it. But this is the normal life cycle of a product in a largely linear economy. We'll say it's a largely linear economy because the recycling concept is very less. When I refer to my discussions earlier in the class on recycling of polymers, we have seen that the highest amount of recycled polymer happens to be PET, and for that also the percentage of recycled is nearly not more than 20-25%. For most of the single-use plastics and other polymers which are used, there the recycled content happens to be the recycled fraction happens to be not more than 5 to 10%. So we are largely living in a linear materials economy, except some of the precious metals which are actually they have gone into circular economy route. And this is one idea, this is one hint which tells me that maybe because they are precious metals, that is why they were already into circular economy. Means economics of the circular economy has to be understood clearly, and that is what we will try to understand in our discussions. Okay, so why we want to change from this linear economy? Because of these reasons. We have already talked about them a number of times, and that's precisely I have taken up this topic towards the end of our discussions because we already by now know almost everything about this topic. So the population is increasing, the affluence is increasing. So your IPAT equation comes into picture. That is the impact on the environment is population times affluence times technology. And if I want to restrict the impact, or if I want to have a constant impact or reduce the impact, because P is increasing, the population is increasing, the affluence is increasing, and technology has to do some wonders for us. Technology also has limits onto it, and that is why the concept of circular economy comes into picture. We say that the increasing population, the affluence which is rising, and the resource limitation, the resources are limited. Not only resources are limited, but we need to talk about one more issue here, that is the waste generation. So with every product that we are making, with every process, with every industrial process that we are referring to, there is a waste generation. Let's talk about a car here. So if you run a car, not only you consume resources in terms of the fossil fuel, if it's an electric car, maybe indirect fossil fuel, if it is not coming from a clean grid. But in addition to that, most of your cars, if they are fossil fuel based cars, they also generate waste, means emissions. And those emissions, that waste is actually again getting absorbed into the the environment. But obviously the environment has a limit that you cannot go on generating the waste without a limit onto it, and that's precisely what we say is that waste happens to be one of the parameters which will come into our discussion regarding circular economy. We may tend to say that we want to reduce the waste, but then obviously we need to go beyond that, even that there shall be no waste at all. How that is possible, let us see. In one example, we'll see it later on. Okay, so this one thing which I already said, that at the end of the life, the product may have lost its life, but the materials are already there. So your car may have lived its life of 15 years, but at the end of 15 years, it still has the same steel, it has the same aluminium, it has the same polymers, it has the same other precious metals, even if they are there. So materials don't go anywhere. They are still available in the same product. And if we are able to take out those materials, that is what we will try, that is what will make the difference, that I don't need to mine, and I don't need to use the fresh resources for fulfilling my further needs. I can use the materials which are available to us at the end of the product life, and don't use the fresh products. Now, that is what we say, that if you have read some books, you may have heard about the three R's. Those three R's are repair, reuse, and recycling. So repairing, reusing, and recycling. So we already have talked about recycling, but we need to increase the recycling percentage. That is what we will see. So by these three R's, we can return these materials which are available at the end of the product life in the product itself. We can still return them. We can take them out and return them to active use. So this will create a closed cycle. We call it as a technological cycle, and a similar cycle which is available to me. What we are trying to say will exist in technological terms. It is already existing in nature. The carbon cycle available into the nature, the nitrogen cycle, and the most easier to understand is the water cycle in your biosphere. So they have a closed cycle, and in this natural or ecological cycle, there is no waste generated. No waste is generated, and that is why we say that it is a closed system. Whatever you consume, you start using it. At the end of it, there are some products left. The materials are still there. I keep on taking out that and reusing them again and again. So we said the three R's, although obviously they are not the new ideas, they have been in discussion, and specifically in countries like ours, we are using them since long. That we reuse them. So our cars don't go out of service even after 15 years. We recycle them, we repair them. But when I talk about the Western world, the three R's were not that commonly used. The basic reason being the labor cost required. You will need somebody to repair it, somebody to recycle it, somebody to reuse it. So the labor cost involved in these three implementation of the three R's was very high as compared to the material cost. The materials were cheap, and that is why the Western world never thought about three R's. But now, as we find that the materials are going less in, what we see, their abundance is decreasing, you are consuming more and more resources, and that is why the cost is increasing. Which takes me towards what we say that even the Western world now is talking about the use of three R's, and circular economy concept talks about mainly about three R's, but we will see that it has something more about it also. Okay, so before I touch upon circular economy concept here, I just can't leave the ideas floated by McDonough and Brat, which are two professors, and they gave a very simple idea. The idea is given here in red. They say waste is a symptom of design failure. Means there shall not be no waste. And why they are saying it? Because what they did, they compared the technological or industrial systems with the natural systems. And they say that because the natural systems do not generate any waste, and that is why they are self-sufficient, and then that is why they have a closed cycle. Whereas all the industrial systems, they always generate some waste, and then say that the design, an ideal design for an industrial system is that we shall be able to design out waste and pollution. Obviously, waste and pollution are related to each other. So, an ideal industrial or an ideal product design shall be that there shall not be any waste generated into it. We already are into the concept of less waste. That means our car are less polluting now. But this idea goes beyond that step. Instead of saying that you are having less waste, it says you shall not have any waste. And on the contrary, the system that you generate must be able to have a positive footprint, a positive carbon footprint. What is the meaning of that? Which we'll just come to this. Okay. So this is the brief idea on what these two gentlemen had talked about. So they say that a biological cycle is what we have seen here. That what is a biological cycle? Let us say I have a cotton plant. I take it to the production unit and make a cotton t-shirt out of that. I use it. At the end of it, because it is totally biodegradable, it will degrade, and the biological nutrients will then go back into the environment, and then those nutrients will be again fetched by the plants, and then the circle is complete. So this is as far as the biological cycle is concerned. And then it comes how the same thing can be implemented in a technological cycle or in an industrial cycle. So you whatever product you produce, let's say it's a laptop here, so I use it after some time. After that I use it, instead of throwing it out in a what we call it, in a landfill, we there is a take back policy. That is what most of the companies are coming up these days. What these people do, they take back the laptop or the mobile phone from you. They may reuse it because they may have a channel again where they will sell it again for reuse. They may disassemble it at some other facility, and after disassembly, what they will do, they will take out the technical nutrients or technological nutrients. So what are these nutrients? Mostly these nutrients are in the form of metals, sorry, no, not only metals, materials which are going into this product. So a mobile phone may have lost its usable life after maybe 2 years because it has become obsolete technologically, but materials are still contained in that. So those materials are then at the end of the life, they are disassembled and then they are taken out. And we are saying we will take out all of them and then use those only for future production of the mobile phone. So what will happen earlier, this production facility was also fed by from here, maybe let's say from here, by the virgin materials. But when I am going to go for a closed cycle here, this cycle will give me some material inputs from here also. That means some of the materials I will recover here, they will go back into the production line. So whatever is there, all of it goes back. So there is no pilferage from this cycle. Just like a natural cycle, there is no pilferage happening here. That's the precise concept of what we call as circular materials economy. Okay. uh, we already said that what is happening is that if you just go back here, we find here that at the end of the life of a product, the materials are still there. So, what happens to those materials at the end of life? This is just an example which tells me that what we are referring to. What it says is that the materials are there, you make components out of that, you make a product out of that. After the end of the life of the product, after the end of the life of the product, I may reuse it, or I may take out components out of that, or I may go back to the materials level. And what these bars are telling us what is the value here. So as you go down this hill here, we find that the value is decreasing. The product has a value, but when I reuse it, the value drops down. But as I go downhill, if I do not reuse it, if I go for recycling, I will need to take out materials here, but then the value goes appreciably down. I may re-engineer, I may refurbish. That is why I will need components. I will not need materials at this stage. The value is pretty high as compared to if I go one step further down. So as I keep on going down this step, the value of the product is going down, and this is one reason why this becomes uneconomical, because you may need to employ labor and technology to collect or segregate those materials, but those materials may not be having that value. That is why your cost will not be recovered. So that's what we find here that is happening. There's one more concept which is an interesting concept to understand here. We are saying here that we do not want the systems to have any waste at all. So when I compare it with a car here, as I said, 10 years or 15 years ago, cars were polluting too much. So the carbon footprint was something like this for a car. So as the time progressed, now we are seeing the carbon footprint is going down. Means the efficiency of the system is increasing. This efficiency of the system has increased maybe because of recycling or downcycling, or it may be having what we say reduction in the carbon footprint here. This has happened because of efficiency increase. But I just want to do not want to stop here. Instead of having even a smallest negative footprint, our ideal must be that our products shall have a positive footprint. Means instead of having what we call them as less bad products, they shall be as good products. So the product here, the car, maybe 20 years ago were very bad. I worked upon it. Now it is less bad, but still it is bad. But what we want that this system, this product that you are talking about here, it must have a positive footprint. Means when I use this product, it shall create something which gives me a positive carbon footprint. The simplest example which comes to my mind here is that of we refer to it in class also, and sometimes that wood can have we can say trees or wood has a positive carbon footprint. Why so? Because we say it is termed as a carbon sequester. Means trees actually what they do, they absorb carbon dioxide and give you oxygen, and that's why planting trees will have a positive footprint onto the ecological aspect of that. So what we want to do from a recycling concept, I want to upcycle the thing. I want to reuse the products. So reusing the products will have a positive impact because why positive impact? Very easy to understand. Reusing a product will have a positive footprint because a new product will not be needed. So I will not need a new product even with a smaller footprint. The product is already there. Instead of throwing it out here at this time, I take it back. So let's say I have a mobile phone. I want to throw my mobile phone and buy a new one, and there is somebody else who is looking for a mobile phone. So one way is I go give this to my recycler. He takes out my mobile phone at the end of the life, take out the material out of that and recycles it. Second is it still has, that means my phone has still a footprint on maybe a minimal one because I am recycling it, but still it has a carbon footprint. How reuse can help me? Now the mobile phone which I am trying to dispose here, somebody else, as I said, is looking for a mobile phone. So instead of this person buying here a new phone, he will reuse it. So there will be reuse of the same phone here, and that is why if this person or the other person would not have bought my phone, he would not you reuse my phone, he could have bought a new phone, and that is why that new phone would have a what we refer to as a negative footprint. But because I saved upon this much of emissions by reusing the same phone, that is why reusing here we say is a type of creating a positive footprint here in not only reducing the the environmental impact of the product, or I can say here that not only being less bad but being a good product. So this is the same, the similar thing which I have already explained, the biological cycle, and here we have the technical cycle. We this approach given by McDonald and Boro is also called as the cradle to cradle approach. Cradle means beginning. When a kid is small, he is into a cradle. Cradle to cradle. The earlier approaches were cradle to grave approach, means I take out a product from the cradle and then use it and then take it and bury it down. But now I will bring it back to life. Guess what is there? You take a product, use the product, return it to the seller. Maybe he may reuse it or he may be disassembling it, taking out the parts or the materials or what we call as the technical nutrients. And going is there. If it is a if it is a product here, if it is a consumable product, we say the consumption product must be normally made up of a biodegradable material. If it is a not a consumable product, at the end of it, like a mobile phone, I shall be able to take out the materials from it and then put it back into the cycle. A consumable product may be a PET bottle, a soft drink bottle. We shall try to make it of biodegradable material, so that at the end of the product life, I can take out the biological nutrients out of that and then put it back into the service, or to put it back into the environment. So this is one example which I did in my last case study also. If you remember that, this was the case study for material selection on ecological aspect as well as on the aspect of price. So we, if you remember, this is a case study which I did for soft drink bottles, PET bottles. We said PET is the best material as on today for making, is the most, not the best material, I say is the mostly used material for making soft drink bottles. So we carried out this analysis earlier in our studies through this through another video lecture here, where we said that when I want to go for what we call as a trade-off surface method for selection of material on multiple objective. One objective was on minimum, what we refer to as the embodied energy, and second was on price. We have seen that PET happens to be a material which is giving you the lowest price, but in terms of its embodied energy, it is having higher embodied energy than another product, which may be PLA, which is a biodegradable polymer. So a PLA may be a better product now when I'm talking about circular economy here, as reference to PET, because we say PET is recycled, but still only 25% of it. 75% of it never comes back. But if I'm making my drink bottles of PLA, all of them will be then used back. They'll be go back into the natural cycle, and this is what happens here. So if I'm making my bottles of PLA, so how do you get PLA? You get PLA out of starch. So you have sugarcane and other things, and then you take lactic acid out of that. You make PLA pellets, and here in place of this, I've taken it from some place, and that is why in place of this coffee capsules, I can say the bottles are made. So after PLA pellets, you are then making the PET bottles. At the end of their life, the PET bottles are then made converted into compost because they are biodegradable, and then they are then put back. This compost is again combined with CO2 and water and biomass, and then goes back into the making of the same plant from which it was derived. So it is a complete life cycle. It's a complete circular economy. Means the material which is entering into its life cycle is not going out of that. The same materials come back again and again, and then it is used again for what we call as consumption. So this is an easier example where we say PLA can be an example of a circular materials economy just by material replacement, that we have been able to use this. So if you now compare it with PET, so you may have created PET out of fossil fuel, so you would have PET pellets here, then you will make a bottle out of PET pellets. Obviously, it cannot be composted. It cannot be composted because it is not biodegradable. So you will recycle it. Reusing is not possible normally for food grade bottles because of the safety, health, and safety issues. So you will recycle it because recycling is not 100%. That is why there will be pilferage, and then I will need to consume more fuel, more fossil fuel there to create more PET bottles. Whereas if it is a PLA based solution here, the cycle is complete. So there is no pilferage here. There is no waste. Means there is no waste generation here. The cycle is just like a natural cycle here. This is another way to look at the things here. Currently, what we are doing is this: we are producing a product, using the product, and then there is a waste. So this is how things are changing with time. Currently, maybe long time back, not currently, the resources were many. So you were taking out products out of that, and then the waste was at the end of the life, you were just throwing it. So over a period of time, the resources are going down and they are getting depleted. So you have less resources here. You are taking out more products because of the applicability of the IPAT equation. You are taking out more products and you are generating more waste. So currently, this is what is happening. So there is one solution to the current problem, which we say is the three R's: reduce, reuse, and recycle. So what we did here, that at the You have a resource here, you make product out of that. At the end of the life, some of it is put back into service. So some of it is recycled. You can try to reduce the production, but normally that is not possible because of the increase in consumption. But what it tells me is that you take out some recycling here, and then at the end of it they're again recycled. So the situation here is not as bleak as it was here, because you have some inputs coming from your recycled products also. But what do you want to do? We want to go for a cradle to cradle design, or a circular materials economy, where we say it's also called as a regenerative design. So what it tells, it says now the resources will tend to become infinite. How they will become infinite? Because at the end of the life, the material is not going out of the cycle. It is coming back. It is coming back into the cycle. It is going, either they will go back into the biological cycle, or they will come back into the technological cycle that we have already said. So no matter how many products we are making, you are increasing the production, but the resources are not depleting, because the materials are not going out of this cycle. They are always maintained within the cycle. And this is precisely what we understand by the concept of circular economy. It's what it does. So a circular economy will actually have a healthy environment for Earth as well as inhabitants. It is perceived that whatever power consumption is there in circular economy, most of it, or all of it, will come from, what are these? Solar energy, wind power, water current. These are all renewable sources of energy. So they'll all be using the renewable sources of energy. The production will use those materials which will have either, at the end of their life, they will have either technical nutrients, or at the end of their life they'll be having biological nutrients. The waste will actually re-enter into the system as a technical or a biological resource. There will be no waste going out of the system, so there is no waste generation at all. It will be similar to what we refer to as a biological cycle there. And similar cycle which can be conceptualized is that of a car. So your old vehicles get dismantled, the metals are then taken out and refined. The whatever resulting material which is coming out of this refining, they'll again use to make new cars. So this is how the materials will never go out of the cycle. What has been happening already, we have already seen that people have introduced, or governments have introduced, take back regulations to before going for circular economy. Means for like for batteries, there are take back regulations that you cannot just throw the batteries there. So there are take back regulations which are introduced. There are mandatory recycling type targets which were there. There were minimum service lives which were given by the what we say laws or the rules there. Another thing which has happened is we have tried to increase the efficiency of the system, both in terms of material efficiency and energy efficiency. And this is precisely what has happened here. So a circularity concept, as we have understood by now, it's a concept which just not only looks at efficiencies, but also new ways or new thinkings in the design. And this is how it is gathering momentum. That is why it is gathering momentum here. And we say now the idea is deploying the materials, not consuming the materials. When I say consuming the materials, I'm saying they are dead. They are not there. We have consumed them, and at the end of the product life, the product materials are not there. But actually, that is wrong. Actually, we are deploying the materials for a particular duration of time. At the end of the service life of the product, I will take out these materials, and that is why we say they are they are deployed rather than consumed. So I'll break here, and we'll continue our discussion on this concept of circular economy in our next